So because of the heat yesterday, my smartboard is not working, which is why I'm having you guys watch this video. The second period is being very nice. So with the product rule and the square roots, doesn't matter if the numbers under the square root are the same. So with this, you just have to make sure you multiply the outer numbers. So 1 times -3 is -3. And sometimes it's beneficial to multiply the inners. So 8 times 2 is 16. So this is beneficial. Square root of 16 is 4, which ends up being -12. Sometimes it's not beneficial. So for this one, there's a 1 here, -1 there. So the answer on the outside is -1. Multiply the inners, 6. Nothing comes out. You could also write this as negative square root 6. For number 5, multiply the outer numbers, which is -35. But on the inside, don't multiply the 10 and the 12, because all you're going to do is get a big number. And you want to make sure you make this really easy for yourself. So with this one, you want to break down the 10, which is 5 and 2, so cross that off. The 12, 2 and 6, so this is your pair. The 6 can be broken down into 2 and 3. So the 5 has nothing else, so it gets boxed. This 2 and 3 gets boxed. So what comes out? You have a -35. The 2 comes out. And what's left inside is your 5 and your 2 and your 3. So 5 times 6 is 30. Clean it up. 35 times 2, -70, square root 30. So for number 4, multiply your numbers on the outside. So we get -4. Take the two numbers on the inside. So 4 times 8. 14 is 7 times 2. Your 8 is 2 times 2 times 2. So we broke those down. Here's your pair here. There's your pair there. This one is a singleton. So we have -4 times this 2 comes out. This 2 comes out. Square root, the 7 goes back in. Clean it up. -4 times 2 times this is -16 square root 7. Now it doesn't change if you have a variable. So for number 5, multiply the numbers on the outside. So you have 4, and then you put the numbers on the inside. You have 6 times 6, and then you have 3 n's. N times n times n. So we have 6's are pairs, we have n's are pairs, and then we have 1 n. So we have a 4, a 6, and an n. Square root n. Clean it up. 24n square root n. Alright, you guys try 6, 7, 8. Okay, so hopefully you guys can see all of your answers. You guys can look and see if you got them right. If you have questions, please make sure you ask me. It's important. If you don't get those answers, please stop the video and ask me questions before you keep going. So let's go down number 9 and 10. Have to make sure that you pay attention to the operations, just like order of operation. And when you're doing it without square roots, you have to make sure that you do it when you have square roots. So we have to do this first. So multiply your outer numbers. So break that down. So we get 30 times the 2 square root 5. So we get 60 square root 5. Bring this guy down. Minus 6 square root 5, which is 54 square root 5. Okay? You guys tried pen. So hopefully you got that answer, and because the x's have the same exponents and then the square roots are the same, you can combine the two terms. Okay, so let's go to the next page. And just like with normal distributing, so let's go off to this over the side, and we have x times 3 plus y. We have that problem. What are we going to do with that x? We're going to distribute. And what are we going to get? 3x plus xy. So the same thing happens with this over here. We're going to distribute that square root of 6 in. So we're going to get 3 square root 6. This one's on the is not in the square root, so you can't multiply that. Plus, multiply these. But we actually just leave them side by side. So this right here is 3 times the 2. This is 2 times 2 times 2. So we broke those down. And there's one pair. There's another pair. That's my singleton. So let's rewrite. Pull out a 2, which is 4 square root 3. And that's my answer. Can't combine because the square roots are not the same. With this one, we're going to do our box method. So 2 times 4 is 8. 2 times the square root of 3 is 2 square root 3. 4 times the negative square root 3 is negative 4 square root 3. Negative square root 3 times the positive square root 3 is a negative square root 9. It's combined. We get 8 minus 4 square root 3 minus the square root of 9. Clean it up. That's this answer right here. Hopefully you said that, because square root of 9 is 3. We can combine these right here. 8 minus 3 is 5 minus 4 square root 3. Now, question. Let's see, hold on. Do this. Shrink this just a tad. It's down there. I have a question. If you have something that looks like this, can you combine this right here? Can you combine the 5 and the 4? Oh, let's not do it that way. Can you combine 5 and 4? Can you combine the 5 and the 4? I'm hoping you said no. And the reason why is because of that guy. Okay, you can't combine because of that guy. Okay, so for these, what you need to do is you need to take the square root of 15 and distribute it through, so it'll look like this. 2 square root 15 plus the square root of 5 times 15, break this down as 5 times 2. So that's a pair, that's a singleton. If we rewrite, we get 2 square root 15 plus 5 square root 2. That's your answer. Can't combine. Let's do 13. No, let's go down to 15. So we're going to distribute. Actually, let's not do it that way. Let's do it this way. Square root of 5 plus 2. Square root of 5 plus 4. Square root of 5 times the square root of 5 is the square root of 25. Square root of 5 times 2 is 2 square root 5. Square root of 5 times the 4 is 4 square root of 5, and 4 times 2 is 8. So the square root of 25 plus 4 and 2 is 6, square root 5 plus 8. Clean this up. 5 plus 6 square root 5 plus 8. Clean it up. 13 plus 6 square root 5. That's your answer. Okay, we're not going to do it, but this right here, I want to make sure you understand. This is 2 square root 7 plus 1 and 2 square root 7 plus 1. This squared means that there's 2 of the same parentheses. So for the next set of notes, it's the same idea, but now we're going to do the quotient rule, where you either can reduce them or you can break them apart. So it would be the square root of A over the square root of B. Sometimes it's to your benefit and sometimes it's not. So for number 1 down here, we break it up. Square root of 49 over the square root of 100. What's the square root of 49? I hope you said 7. Square root of 100, 10. That's your answer. With this one, it is better to reduce. So let's clean it up. Put it its own square root. Square root of 1 is 1. Square root of 4 is 2. For this one, nothing you can reduce. So put it in its own square root. Square root of 3 stays. Square root of 16 is 4. Now, the biggest thing you cannot have So the one thing you cannot have is a number over a square root. Number over a square root. So for number 4, it's not to your benefit to actually reduce this. So the square root of 7 over the square root of 49 is equal to the square root of 7 over 7. You can't reduce this because one's in the square root, one's not. With this, you want to reduce it. So we're going to put it back in the same square root. If I take a 5 out of here, I get a 2. Take a 5 out of here, I get a 9. Break it up. 2 over the square root of 9. Square root of 2 over 3. Number 6, again, put it back in the same. Whoa, what happened to there? Not sure what happened there. Pen decided to go crazy. There you go. Reduce. Gives you 1. That gives you what? If I do 12 into that, it's not to our benefit, because then we get a 3 here. It's not a good thing. So let's back up. So what could I reduce by that would give us perfect squares here? Well, if I reduce this by 3, or if I reduce this by 4, reduce it by 4, we get 3. Reduce this by 4, we get a 9. So if we clean this up, 3 over the square root of 9, so the square root of 3 over 3. So sometimes it's to your benefit to kind of pay attention to what you're reducing. Number 7, let's put it back into the same. So we get 96 over 3, and 3 goes into this 32 times. So we get the square root of 32. That breaks down into 4 and 8. That breaks down into 4 and 2. Here's my pair. That's my singleton. My answer is 4 square root 2. So for this one, that one will reduce. This one will reduce. Okay, so if you flip over to the back of that notes, we're now going to do rationalizing denominators. So to fully simplify, no radicals can be left in the denominator. That's what I was saying on the other side. My line does not want to behave itself. There we go. So you have to rationalize your denominator. So the way you do this is, because we can't have a square root in the bottom here, you're going to multiply. You're going to multiply by the square root of 7, top and bottom, because you can't have this in the denominator. You don't care if it's at the top in the numerator. You just can't have it in the denominator. So what does that do? We're going to do the baby steps here. So this is 4 square root 7 over the square root of 49. 4 square root 7 over square root of 49 is 7, and that's your answer. Okay, for this one, you're going to multiply by the square root of 2 over the square root of 2. So we get, these are not pairs, square root of 10 over the square root of 4. When you get the square root of 10 over 2. For 15, you need to break it up into their own square roots. And then we need to multiply top and bottom. Now what's the square root of 81? 9 over 2. For this one, put it in and can we reduce this? Of course we can. 1, 3. Put this in its own square root. Square root of 1 over the square root of 3, which is 1 over the square root of 3. Multiply top and bottom by the square root of 3. So we get square root of 3 over 3. Okay, so for the next one, multiply top and bottom by the square root of 2. We get 4 square root, so 3 times 2 is 6. Square root of 2 times the square root of 2 is the square root of 4. So we get 4 square root 6 over square root of 4 is 2. Now when you get to this spot, if you can reduce, you need to reduce. So this can be reduced right here. You can't reduce inside, but you can reduce outside. So for 18, you only have to do the square root. You don't have to do anything else. And this can be simplified right off the bat. So this right here is going to be 2. So we're going to get 2 over 10 square root 3. Let's just reduce this right off the bat. Let's clean it up before we do the other. And now we get rid of the square root. So we get the square root of 3 over 5 square root 9 square root of 3 over 5 times 3. So the square root of 3 over 15. Okay, last two. So for this one, ooh, that's a really bad line. We're going to multiply by the square root of 8, and that's going to give us, you know that there's two ways you can do this. Let me erase this. You choose. You can either break this down, or you can multiply it the way it is. So here's the first one. You can multiply by the square root of 8, and that equals over 2 square root of 8. And we know that this is 2, 2, and 2. I am really, really close to go out here. So this is my pair. This is my boxed. That's my boxed. This is my pair. So on the top, I'm going to get 2 square root 6, and on the bottom, I'm going to get 16. And I'm going to reduce this, and I'm going to get square root of 6 over 8. Now, the other way I can do this is, so that's if I take it out that way, is if I do this. I can break this down right now. That goes out, that stays in. I have the square root of 3 over, this goes out, multiplies, that gives you 4 square root of 2. So now all I have to do, my pen is acting up, is multiply by the square root of 2. Oh, please don't talk. Okay, so this is going to look like the square root of 6 over 4 times the 2, which is square root of 6 over 8. So I want you guys to try number 24. Stop the video and try number 24. And then once you finish it, then turn it back on for the answer. So once you hopefully finished 24 and did all your work, you got the same answer as I did, which is the square root of 15 over 3. All right, that's the end of the notes, and I will now be giving you some homework. We'll put the computers away.